So welcome everyone to this webinar on finding the right Kubernetes operating model. My name is Franz Schubert. If you joined later, and I actually have lots of discussions around what value Kubernetes provides and how to operate it in an environment at the very beginning of a relationship. And we actually have these discussions together with clients that actually are thinking about going on the Kubernetes path. And then we naturally start off with discussing a couple of items that I actually have condensed in this presentation. And I also want to share some, let's say, typical considerations that clients actually have discussions with me about that I actually would like to share with you, so you can basically then see and match if you have the same considerations or if you actually would like to add anything. And basically get a little bit of feedback of what others are doing. So you can then basically be better prepared, taking the right decision in terms of operating your Kubernetes environment. So let's jump in. I think the most important thing, if we actually talk about the Kubernetes environment, is that if you actually look at traditional infrastructure teams, they typically take a very, let's say, standardized perception or perspective onto Kubernetes, very similar to operating their Linux environments. I actually had discussions with infrastructure teams where they say, well, it's just a scripting tool, so there's not much about it, we just install it, we configure it, monitor it, and then we fix it or patch it and upgrade it and be done with it. That's naturally one perspective you can take, but then the question is, why do you actually do Kubernetes? Because then, may as well run it on VM, your containers on VM, and be done with it. If you actually really want to, invest in Kubernetes, which is a significant investment, then you actually better need to make sure that you generate the best value and the most value for your organization out of using and going this path. And that's why I think it's very important to really think about Kubernetes very, very differently. So Kubernetes is, it's a technology, naturally, but it actually is there that helps your organization to make your software development teams more productive. And by abstracting that, like, say, the complexity out of the applications, that's how you actually can achieve the higher innovation rates and the faster software development, the scalability, and many other aspects that you would have to develop then otherwise. That's how you actually basically generate the benefit, and that's what you as a operations team need to focus on, is how can you empower the software development teams to really benefit from the technology, and also the horizontal services that you can then provide by abstracting that complexity out of the applications. And if you actually look at companies, and let's take Adidas, for example, we've been working with them for quite a while, and if they actually had taken the traditional approach, they probably wouldn't have achieved the speed of innovation. And for them, it actually was very, very important to really think about. So I don't know, probably most of you don't know that story, but about 7-8 years ago, actually most of their systems were based on SAP, and as well as their online shop, and they actually had to take a decision if they actually want to build up their online business, how they actually would go about it. And we had a workshop with them around cloud-native technologies and modern software development, and they actually quickly figured out that they actually would like to really bring agile software development into the organization, make sure that they actually can have very high innovation rates for their online store, and that actually led to them going Kubernetes full swing, also cloud native full swing, all the training. And in the meantime, they actually have a huge innovation rate in the online stores. They've got several hundred developers now working on this. And they actually were able to grow their online business 100 times within just a couple of years. So they actually went from 40 million to 4 billion in revenue. And especially in the last year with COVID around, that actually really saved their ass. So this is what we're talking about here. We're not talking about another technology that you just need to operate or just install and be done with it. This actually can or has the impact that on the whole of your organization, and it really depends on where you are and what your strategy forward is. But that's where basically you actually need to consider what you can achieve with it and how you can get that value into the organization by making sure that the software development teams don't have to worry about it. They basically have the API that they can commit to, and that's it. If you look at the other two components here, these are components that are important, but I actually won't focus on my talk today. So the technology components that basically are the building blocks, making sure that you can deploy and run your workloads in containers in a very scalable fashion. There are differences in technology. The question is, are they actually relevant to you? And that's completely different discussion. It depends a lot on the size and the maturity of your organization in terms of Kubernetes, where you might be running 1 or 2 clusters. Then Kubernetes is fine. It's built for that. If you actually run 40, 50 clusters, or we actually run several hundred clusters for our clients, then it actually becomes very quickly a question of how do you manage multi-cluster environments. And we actually, for example, developed an environment. We built Kubernetes on Kubernetes to make sure that actually works really nicely. But that's, again, as I said, a different discussion, not part of our speech today. Another part that actually isn't is something I won't focus on a lot today is the evolution aspect. It's a pretty modern technology. I know, agile software development has been around for quite some time now. Then containers and microservices have been around for another, let's say, 10, 15 years. And Kubernetes actually at least another 5, 6 years. So these are elements that actually develop very, very rapidly. There are certain concepts that are still let's say evolving rapidly. That's why open source is a key driver in this field, and the huge investment that actually go into this software development, or the software development in terms of the infrastructure layer, are quite significant. And that's why you actually need to think about how you want to evolve your environment and make sure that you benefit from it. But that's, again, something actually we won't focus on today. Today, operations is king. And and picking the right operations model that actually makes sense for you can always and needs to be always seen in that context. But I hope I covered the aspects sufficiently so you can actually make that decision very easily for yourself. Now, let's go to the next slide. There are different ways of looking at, let's say, what the right Kubernetes operating system or operating model might be for you, and I think the typical aspect is look at similar companies, look at companies at the same size, or the same nature of business. There are companies that are really huge, but their innovation capabilities are more in the engineering field. They produce physical products. And you probably could say the same for Adidas, but they actually still have to find the online strategy to be elementary to their business, and also the way they actually interact with their customers, that you can order to build shoes, that you can have, let's say, a shopping experience. In reality, it's a commodity, it's sportswear, but they actually managed to build a brand around it, to build hype around it, and that actually made them really, really successful, especially with the high innovation rate they are capable of today, and the ability of really scaling to an extensive level. So the question is, there are so many different customers or companies out there. They have different sizes. They actually all take different approaches to some extent. And when we actually looked at the companies, we actually found so many exceptions that we ended up with this model here. And it actually allows us to really discuss how you actually pick the right model, more depending on your journey and the stage in your journey, rather than your current state or the size of the company or the nature of your business. And I think that actually should also help you think about your operating model as something that actually will change over time. It's a very natural process where you actually might start off with something. Let's say you install something very easily yourself, play around with it. You use Kubernetes from one of the public cloud providers, you play around with it. And then you might bring out let's say an MVP and try out the MVP and see if it actually flies at all and if people get excited about it. But then eventually you might want to think about it differently, because there are certain aspects where, let's say, the UX experience becomes very, very important, or your innovation rate becomes important, and you might then consider your Kubernetes environment very differently as a let's say, a very important component in your path to success. And that's where you then might consider that different operating model actually would suit you. For us, to be honest, there are three very distinct levels where it actually becomes very interesting for customers to discuss, and where they end up taking very similar choices. There are always exceptions, but I think I'll be able to highlight these later. It's when you actually are initially in the stage where you're trying out Kubernetes. We've got single projects or several single projects that actually go on Kubernetes, and that's basically what we call the cloud native migration. That's where basically your company might start off with individual projects, bring these projects onto the Kubernetes, but then Kubernetes is, let's say, an enabler for the initial phase. Get it live is the most important part of it. Operations is more in the whole context of the application. So it's not only Kubernetes. It's in typically it's either it's important and it needs to be up 24/7 and very responsive, or it's not. And if it's not, then typically developers take care of Kubernetes at the side. If it's something that actually is important, that's where typically the teams don't have the knowledge and experience to manage it, or not even the legal capabilities to do that 24/7. That's where a lot of, let's say, service providers come in and actually help out managing this environment, typically also with a lower complexity. But that really depends on a little bit on the use case. But as I said, it's like, this is like individual project, but there are many decisions that you don't have to take up this level. You don't have to think about multi-cluster environments. You don't need to think about governance and security for larger amounts of teams and things like that. That's where the focus of your business is really getting your project live. And actually that dictates a lot around the decision whether you actually, let's say, get someone who sets it up for you and you manage it as a side to the whole project, or you actually get someone who actually more takes the holistic perspective of your application and make sure you actually can focus on developing, but operating it 24/7 is something that basically you actually get a lot of help with. The second stage is where you basically expand within the company. So you've got your individual projects that basically build up cloud native environments, and then they basically think about how can we now make sure that the whole organization benefits from these horizontal services. So really abstracting technology away from the developers, making sure that they actually can use what has been developed for other teams as well, and also benefit from the operational structure around a standard platform, basically, that then they actually can build and bring a lot of new projects onto very, very quickly. And that's where typically the infrastructure teams play an important role, because the operating Kubernetes at this stage becomes more like the standard platform, and then you actually build a platform. Kubernetes in general is a platform to build platforms, so that's where you actually build your own individual platform for your teams, depending on the use cases you have. And you actually try to start off in a very standardized fashion, but typically, and that's really depends on organizations, if they actually evolve very rapidly, then they will come up with new ideas and new requests constantly, and that actually puts a lot of pressure on the teams, and that's where they really need to figure out. We've got many discussions with companies that basically say we only have like 5 or 10 people taking care of Kubernetes and the cloud native stack. So like, and there are so many requests from the departments to actually support different use cases. We actually don't know how to cope with this. And that's where then basically you might think about and enter the third stage, where you think about your platform and about, let's say, going full swing on cloud native, where you might want to support different use cases. You might think about different, let's say, different use cases that are supported on one platform and other use cases that are supported on other platform. You might want to think about multi-cluster environment, multi-cloud environments. You might think about let's say different security concepts, about cost optimization. And I think that happens at every stage, is where either you actually stay at the stage and then it's more a question of optimizing the environment, or you actually evolve and you go to the next stage and really drive this forward constantly. And at these breaking points where you actually, where there's a fundamental change in the setup, that's where it actually becomes very relevant to rethink about the operating model that you actually have and think what actually suits me best. So I think the key takeaway here is don't perceive this as a one-time decision. This is something you will have to constantly evaluate. And we're actually seeing, nearly every client we are working with constantly evaluates what they could do better, how they can optimize, either from a cost perspective or from a capability perspective or from a speed or reliability perspective, and actually try to find this, the best model along this along the journey. And I think that's something like a concept that will help you think more flexibly around picking the right Kubernetes operating system or model, just to make sure that basically you take and you pick the model that actually works for you from the facts you have for now, but also for the future. But then also be prepared and build it in a very, very modular way, so you can actually switch very, very easily. And that's something that you definitely need to consider and take up in your discussions, but also with the teams. That basically it actually is built up in a very modular way, so you can actually exchange and switch the technology out at any time to make sure that you actually really take the benefit from this technology and this whole approach. So if we then have this perspective onto operations, then the question is, what do I need to consider in terms of operations? Actually, I took these standard stages that we basically have here, where you basically install the technology, you secure it, you manage it, you monitor it, you fix it, and you upgrade it. But then the question is, how is that different with Kubernetes, and what do I really need to watch out for? If we actually look at Kubernetes, it's not only Kubernetes, but you very likely already know about all the different projects in the CNCF. Naturally, you don't need all of them, but you actually will have easily about 20 to 30 components installed together with your Kubernetes. As I said, Kubernetes is a platform to build platforms, so you actually will start off with Kubernetes and etcd and all the, let's say, CloudFormation or whatever you actually will be using, public or private cloud provider. If you use your own data center, you actually will probably use some virtualization, and then you actually need to build upon that. So this is where basically you actually will have to either pick or select the technology you want to go with. There are more than 100 distributions out there for Kubernetes. Most of them actually are open source, and then basically they charge for different levels of service. Either it's providing upgrades, testing support, or even running it for you. But then basically that's where you constantly need to also think about what additional components you need to install and the apps you need to install. And once you actually have installed them and configured them, you naturally need to think about security, standardizing on security with robust access, naturally, pod security policies or open policy agent. For the stack and naturally also for the apps, this is something that actually will have and take up a lot of discussions because typically once you start off on a cloud native journey, the security concept changes, and that's where you need to think about how you can actually improve this and change that model around to make sure that you actually achieve these high innovation rates. So the traditional approach to security might not allow you to achieve the goals that you actually anticipated. And that's where the management actually comes in, which is something that, it's not making sure that the technology is there and it stays up and running. It's really managing the whole environment. So talking with the different teams, discussing how to actually cut different clusters, how to set up different teams within these clusters, access rights, how you can upgrade, how you can make the best use out of the resources, how they actually will implement the security, the governance of setting up clusters and these access rights and the apps that are installed, extending and finding out what new components they actually will need to improve the either the performance of the application or the performance of the team or reduce the cost. So this is constantly evolving, and management is a very, very important aspect, very time-consuming aspect in this whole journey, and that's something that you definitely need to consider. The next aspect naturally is monitoring, making sure that you actually have set up your monitoring not only for your environment, but also setting up thresholds, understanding how alerting actually works, when you actually can take, let's say, the experiences from the past and apply them to the environments, making sure that you actually can take a look at things before they break and before they go down. Make sure that you can understand and isolate issues to figure out how you can actually improve the resilience of the application, but also, or the environment, but also make sure that you can deploy all fixes across all clusters without a lot of effort. So that's where automation actually comes in, which is another aspect of management. Thinking how you can basically save time of your team by automating as much as you can, and also making sure that you've got a standard environment where you can apply these fixes in a very standardized approach. And then also the aspect of upgrading, which if you actually abstract elements out of the applications and put them into the Kubernetes layer, you'll have a much bigger dependency to some extent. You actually need to make sure that they actually run. You need to test them, but you also need to make sure that the applications are then built in a cloud native way that you can just pull out machines or nodes underneath and parts underneath them and replace them. Make sure that you've got the application running on several parts. Things like that if you actually are in the cloud native space are very trivial, but if you actually are starting off on the journey, is something that you get to know and learn later on. And that's where you actually really need to understand how you can enable your software development teams to understand the cloud native principles and develop them so your life becomes a lot easier. And since that actually doesn't never ends, it's naturally a whole life cycle. So you actually then need to reevaluate what apps you have, what environment, how to secure them, how to improve security, even outsourcing. Like you might need to build up firewalls, or you outsource that to Cloudflare or other services that basically can help you establish completely new services and deliver, let's say, highly secure environments a lot easier and a lot faster, and manage that, go on and on. So basically, you need to go through that cycle over and over again, and that actually takes quite some resources, especially since, but it's actually investment. Well, it's money or time well invested if it actually helps your software development teams advance a lot faster on the innovation cycle. And I think that's where it actually comes in. It's like, either you actually perceive it as a the checkbox, install Kubernetes, move your monolith onto it. Then, basically you don't have a lot of coordination. You just run it, but then, the value add is very, very little. And then the question is, should you go Kubernetes on Kubernetes at all? Or actually, do you really want to provide value to your organization? And then the question is, how much time do you need to invest to get this up and running? And typical teams are, around 5 to 10 people. So this is something that you actually will see quite frequently, and need to understand how you want to provide this service, and how you want to make sure that all parts of the organization benefit in a very similar fashion. So with that background, and before we actually come to how you find the right operating model for your organization, it actually, let's say, there are different models that are available to you, and typically I actually try to split them up in four models. One is naturally the do-it-yourself approach, where you basically install and upgrade everything yourself. You take full responsibility. This is something that we actually see less and less happening. Just because there are so many, let's say, Kubernetes distributions out there. It was something that is like lots of companies did at the very, very beginning. If it's Capital One or Zalando or Monzo, these are all companies that basically use the upstream projects and build the platform from scratch. And they actually have been doing that for many years now. And at that time, technology wasn't that far, so they basically had to know the intricacies of the modules they were using to really get the use cases going. And for them, at least most of them nowadays would say they would never do it again. But at that time, they actually had to make a decision, and at that time it actually was a good decision. And now they're like reconsidering what actually is the best approach. I think many actually will see the investment they have done and the people they have built up and the knowledge they have built up. So they might continue with it. But at that time also, modular concepts weren't as far as they are today. So this is something as a learning we can take with us, is really to focus on building, building in a very modular way, so we can actually switch out things very, very easily. The other approach is using one of these distributions that you actually can either download for free, or you actually get them within a certain support contract, and can license that. And here, just to make sure, is like you actually are then responsible for installing the software, running it, upgrading it, and so on and so forth. Typically, that's something we see in the on-prem environment a lot, and that's something that actually still takes a lot of time on your end. And something that makes a lot of sense if you, let's say, want to do multi-cluster automation. These packages typically have, at least there are some of them that have these multi-cluster automation already built in. Some of them provide CI/CD pipelines and so on and so forth. So you actually can save some time by making sure that you don't have to reinvent the wheel by building that automation yourself. But at the same time, you actually really need to make sure that you can manage it 24/7 and know the details about all components, so you can actually make sure everything stays up and running. And then you actually have a model where you've got managed Kubernetes, where you might use one of the public cloud providers, where you've got shared responsibility. They take care of the Kubernetes API, so the management cluster. You take care of the workloads, but then still it's your job to make sure that if something goes wrong in the workloads, to make sure that you basically isolate the issue. If you want to use the resources more effectively, you need to figure out how to do it. You need to look up different apps and figure out how to configure them. You need to make sure that you actually, you've got certain limitations that you need to go around. So there are many things that you actually need to consider. The benefit naturally is you can get started very, very easily. And that's actually, I think, the biggest benefit. The question is just like at some stage you might become too mature for that, and then the question is like, how many clusters do you have? Do you actually want to waste your developer resources on managing the clusters individually? What about governance, transparency, up to billing, cost reduction, on cost optimization? So there are many aspects that you still need to take care of. And that's why some organizations actually go forward with teams that basically provide Kubernetes operations with an SRE team, and they actually can then still have platform teams, so it's still a shared responsibility model. But these platform teams then can work a lot with the software development teams to understand how they can actually help them with automation, with, let's say, tools that help move from one cluster to another, have special security requirements, special, let's say, apps that actually help in their software development. We just had an internal customer event a couple of weeks back, and that's where Shutterstock, for example, said that they're using Keda for auto scaling, and they basically were capable of saving about $120,000 to $140,000 a month. So these are things that basically where you can actually get a lot of impact if you've got time to take care of them. And this perspective that we actually see right now here excludes the technology to some extent, because yes, I talked a little bit about the automation that you already get, that helps you become more efficient, but it also excludes all the empowerment for the development teams that you actually also have to invest in to make sure that upgrades happen very seamlessly, that you don't have to support old systems because upgrades can't, or the applications will not survive the upgrades. You actually will be able to think about, let's say, how to optimize your spend, how to allocate costs, and so on and so forth. So there are many aspects that I see more in the evolution phase that basically are not included in here in this perspective. So there are other components basically that you need to take care of, and where you actually have a shared responsibility always. But the question is, like, how big is your team? How fast do you need to advance? And how can you make sure that the value is perceived within the organization? Which brings me to the point on how to make a best choice. So as I just said, there is, there are, let's say, three aspects that I typically bring up when it comes to Kubernetes operating models, where you actually then think about the goals you want to achieve. And the goals that you want to achieve, are either, let's say, you want to go live for a certain date. You want to, achieve a certain functionality. Let's say Black Friday. You actually want to go live on Black Friday and make sure that you've got your new website up and running. That's where companies typically need to make sure that everything is there and ready. And that actually is quite challenging for internal teams that don't know the technology yet, and build up that knowledge. Find it quite difficult to accomplish, to deliver on time. That's where basically that's where many companies then turn to external help to make sure everything stays within within the time frame and achieve the goal of going live, because let's say there is a lot more value having the website live before Black Friday than after Black Friday. And that's where, basically the focus might lean more towards external help than learning and developing things internally. The other aspect is let's say, take quality for now. And here I actually mean response times, uptime, resilience, scalability, so many aspects that actually make a big difference. Here also is, depending on how important and how big the priority is for your organization and the application that is there, it actually might make sense to actually work together with external companies and experts that help you build up that knowledge internally very, very rapidly, and allow you to focus on the improvements rather than the basic setup. And this is something where, it's best or easier for you to allocate the time you want to spend on this. But just to give you an idea, like I think Amazon does about $330 billion revenue in their online stores, and they actually found out that if the loading time of their page was 1 second longer, they probably would lose about $1.6 billion in revenue every year. And that actually just gives you an idea of how big the impact can be for your different use case. And that's something you actually just need to figure out, is like what are the applications you're running? What impact does it have if I actually can deliver the service in a much faster way, if we can increase innovation rates, if we can reduce deployment cycles, increase deployment cycles, reduce deployment times. So like, this is where you actually really need to think about how can you best help the organization. And the third element is our favorite, Kelsey Hightower. It actually is the cost aspect, but the cost aspect from a different perspective. So like the biggest cost you actually have are your software developers, and the more you can make or put them to use for something that actually makes a difference, the higher the productivity, and actually that's the time best spent. And that's why I actually put that quote in there. You really need to make sure, if you actually want to trade resources or time for money, just make sure that it's actually a smart decision. So if you look at this triangle, the further out you are, so the more time critical, the more productivity critical, so more innovation focused, and the more quality critical there are, the more you will need help from external sources to actually make sure that you can achieve these goals. If the value of spending money for external know-how and experience and capabilities is lower than what you actually achieved through time, quality, and productivity, the more you actually will focus on using external resources to actually help you with operating your model. The more uncritical it is, the more likely it is that you actually can do fine with your internal resources. Let's say we actually have customers that basically then say, well, it actually doesn't matter if the server is down 24/7, doesn't matter. If the server is down, we'll come into the office next morning, I'll just restart the pod or whatever, take a look at it, fix it. We'll be done in another half an hour. That's fine. It doesn't hurt. Then that's something that you might not want to consider important enough. If it doesn't matter if you're done in this month or next month, or you actually, we also have customers that expect they will be done way before the development teams are done, then it's not time critical. Then you can go through the whole cycle yourself. Or if you actually have an infrastructure team that actually is interested in this technology and wants to develop into this new world, then productivity is not as important for the developers you put in there, because like the benefit you will get out of someone who actually really understands the cloud native way of providing infrastructure will be a bigger value than the rest of the the alternatives that you'll be watching out for. So these are like that's one way to look at it, and that's where I actually go in the discussions with customers. I basically try to go through all of these points to make sure that I fully understand the value that we can provide, or if it actually makes more sense for the customer to build that up themselves. Another way of looking at things are like, we always are focused on what the here and now, but we actually talk less about the future. And sometimes we actually don't know what the future will be. So if you actually look at organizations, and as I talked about, like individual projects going live, the first innovative products, that's where lots of organizations actually try to focus on, let's say, out of the box functionality, as well as let's say using the standard. So really saying, well, let's go live, but make sure that we actually use out of the box functionality. If there's a EKS or a AKS or a GKE, let's use that. It's unlikely we will ever need more than they provide. To some extent, that might be true if you actually look at individual projects and you actually just want to move functionality, build the applications instead of monoliths in microservices, and then want to run it in a scalable fashion, use the resources very efficiently, then actually that might make a lot of sense. And that's where you basically really, that's why I put it there, like out of the box. If that's what whatever they provide is sufficient, then that's absolutely fine, and you probably will have little effort in managing that environment. The more you look at projects that are coming, even if that's standardized, the more you need to think about scalability, and that's where typically a lot of scripting happens, where you've got then everyone reinvents the wheel with multi-cluster management, with governance, making establishing huge infrastructure as code monsters, GitOps, and all these things actually make sense. But it's just a question of how much time do you want to invest in that, and how do you want to then manage that? So you actually don't build up something that is unmanageable. Don't go from a monolith that is difficult to manage to an environment where you can basically have something else that is basically not really automated to the extent that you actually can provide the scalability and the efficiency that is requested for standard use cases, but with many, many different projects. So here, you need to look at scalability and how actually that can be provided. And that's where, basically you need to think about either automation or building up something that actually makes your operation then very, very efficient. Because that's where you will not be adding additional use cases. And if you actually have an organization where it's more a question of like getting the fifth service of a similar kind online, then you basically will know your stuff very, very well within a decent period of time, and can provide for automation around that. So that actually shouldn't be a big problem. When it comes to more use cases, it actually becomes interesting because that's where the flexibility kicks in that you then need. You need to think about, let's say, depending on where you started off. If you actually started off with the many use cases from the very beginning, you will probably look for a system that provides everything. Probably not likely to find, but you might see yourself overwhelmed if you started off from a more like out of the box model and then try to add functionality over time. And that's where basically then, if you've got many projects and many use cases, you will evolve into more multi-Kubernetes environment. And just give you as Vodafone as an example, they basically decide they will have 3 areas. One where they actually will focus on innovation, and where the teams actually need a lot of assistance in creating these, this very valuable applications. And then the second column was more for the standard SaaS offering. So if you actually get SaaS software or the software that you want to then offer as SaaS, then you basically have a second tier of a Kubernetes system, a different Kubernetes system, and then a third one where that's very efficient, by the way, and then in terms of cost. And then the third one actually would be something like network functions, where you have edge clusters and different use cases. So they basically decide they will have more or less 3 different Kubernetes environments that actually they will propose. Naturally, every department is independent to pick whatever they want, but they actually, in their ideal enterprise architecture outline, that's where they basically already decide to go on a multi-Kubernetes environment that then basically make sure that they can combine the best value to cost relation to the use case that is actually proposed. Yeah, that's where you basically need to think about, where are you going in the future? Am I going full swing? Do I want my whole company to go cloud native? Then it's about building components in a way that if I build something that is specific to my company, it actually is behind an API and I can access it from wherever I want. If I actually know it's more like scaling, then go with maybe a very cost-efficient model, but think about how much flexibility you will need, because that actually will then hurt eventually. And that's where you basically will end up in a multi-Kubernetes environment. So think about the different models and how you want to go about them. It's very likely that if you actually want to go with scalability and flexibility, you will use more the outside help. With out of the box, you probably will be able to find a SaaS offering that actually surfaces. And then with the multi-cluster environment, you will have different models to go forward with. And then, we actually have other aspects that we already seem running out of time again. So we actually have frequent considerations that we go through with different customers, and the customers have brought up. I just want to share them here just to give you an idea. For example, developer impact, so understanding what impact it can have, the platform can have, and a very good operations model can have for your software development teams. Make sure that you can provide training or improvement in terms of the services you're offering, the tools that they might need, but also the support and guidance to make sure that they actually don't have to find out things themselves, but you're there to provide that as a guidance, also from a technology perspective. So telling them where the error lies or how they need to set up different things. That's one aspect where you might want to think about using external services in addition to the internal ones, because you then want to have the Kubernetes environment managed, the standard managed by someone, so you have time for making an impact on the development teams, and basically achieve a very efficient model where you can, let's say, on demand, develop the organization further to increase the value from the platform. Another aspect is anything related to people. So you need to think about, can you get resources? How easy is it to get developers, good developers? How to retain them? They also need broad skills. That's 30, 40 components, whatever you be managing. They need a deep knowledge in some areas, especially if you've got multi-cloud environment. You might need to have knowledge in AKS or in Azure, in AWS, maybe on-prem. So you might have more resources to do that. If you can get that, that's fine. But you also need time for building automation around it, so it becomes a lot more efficient. Then you've got platform automation that you need to think about, as I just mentioned, multi-cluster management. I already talked about governance, configuring things automatically when teams spin up new clusters in a self-service model. Also security and observability that you then might provide. This is where you actually basically can end up investing a lot of time with day-to-day tasks that don't help you really advance the platform. And we've got many discussions around that with clients that basically have been running, their Kubernetes for a while, a year or two, and then basically have the feeling that the team is actually just busy doing the day-to-day work instead of really advancing the platform. Cluster management is here another aspect, understanding how much time goes into upgrades, coordinating that between teams if they're on the same cluster, making sure that you actually don't spend resources too widely, testing things when you actually upgrade them, versioning, so you know what cluster version something is running on, and if it has been verified and tested, which is not only Kubernetes version, but and the configuration, but also etcd and node exporter and so many other things that need to have a fixed versioning to make sure that you really know that the production environment is equal to the test environment. And actually, recommendations, or just trying, that's what Vodafone does. For example, we've got an upgrade window, and in that upgrade window, even if there's no upgrade, we'll just restart pods and then see if the applications survive. And if they don't survive, then the development teams already get feedback that they actually need to improve the applications and make sure that once they reach production, they actually don't go down. Issue resolution is another big area where teams actually don't feel necessarily comfortable digging very deeply into certain areas. Might not have the technology set up, if it's monitoring, tracing, logging, thresholds. That's where external help might be very, very helpful, and that you actually can have an environment where you basically deploy fixes to all environments at the same time, instead of having to doing that manually. So that's another aspect of increasing flexibility. Legal requirements, if you actually don't have the capability of running 24/7, then that's naturally something where we actually have run into discussions where we just need to upgrade it for the customer. There are lean ways to do that, at least from a legal perspective, and then there are ways to do it properly, where you really where it makes a difference if something is down in the middle of the night, and you actually really want to get it up and running because it's in a different time zone or whatever the service you're providing. Then naturally avoiding lock-in, making sure that you actually have we don't use proprietary extensions or technologies. Also things like convenience is a lock-in. If you actually go to a public cloud provider, you actually will get the monitoring. It's a one-click install. It just creates another lock-in, which is fine for many companies because they're already committed to a single cloud provider. But it's something to be just aware of if you want to change at any stage, or if you actually want to then move on to multi-cloud and multi-Kubernetes environments to actually support that. That's something that probably will go away a little bit in the future, just because of Cluster API, something that actually we'll be speaking about in a very short period of time, where it'll be possible to then manage Kubernetes environments or clusters from different Kubernetes providers from a central control plane or management cluster, independent from the provider that you're using. So it will be a lot easier then to mix the different operating models within your company and make sure that you actually basically can, you're not locked into a certain element that much as you are currently. And actually then the degree of freedoms, like, how much freedom do you need to manage things, to do root cause analysis, and basically, how much personal assistance is it handy to have to make adjustments to the environment that you have without then being fully responsible for them. On top of the hour, just a couple of things, decisions that actually really have an impact. So think about the cluster topology. This is something that is not easily changed. If you've got a cluster, like many teams on a cluster, or a cluster for every team, it actually will have an impact on cost, and will allow you and will take away a little bit of the flexibility, but naturally can increase the efficiency if you have a lot of people on different clusters. It actually becomes more efficient for you. If it's many customers on or projects on a single cluster, it makes it cheaper for the cloud provider or for whatever service you're using. Networking topology is like, understanding what impact it has between your maybe on-prem data and the cloud providers, and actually also security. Thinking about the investment into security and how that actually will change over time. I'm already over the time. Thank you very much for attending this webinar. I actually hope you found it very useful. And we'll actually hand over back to Tommy for questions and answers.